In this video, we are going to learn how to build a simple gear sprocket hardening case using symmetry approach in CENOS Induction Heating simulation software. Sliced cases are cases where only a part of a full 3D geometry is being used for the simulation. This offers faster calculation without losing accuracy. Geometry is the beginning and the cornerstone of every simulation, so we need to start by preparing our geometry for the simulation. First, you need to make sure that your CAD files have been created correctly. Make sure that the whole geometry has been cut at the same plane, the black lines you see here. Even small deviations of the geometry from the cut plane can lead to problems during setup or calculation. We also suggest centering the geometry around one of the axes, X, Y, or Z, since it will help with result visualization later on. However, it is not mandatory. If you choose to add your own airbox as well, make sure that the previous points are true as well. It is cut on the same plane and is centered around one of the axes. If everything has been created correctly, then CENOS will have no problems generating the airbox for you. Once the geometry is prepared, we can move on to case setup. Since we have created our own CAD files, we need to select the geometry creation approach. In CENOS Home window, click Import CAD. Click the blinking folder icon to select the CAD files you want to import. Select step files in your system and click Open to import them into CENOS. You can import each geometry object in a separate step file or all of them in a single step file. It really doesn't make any difference to the simulation. Once the CAD files are uploaded, CENOS will ask if you want to automatically generate the airbox, ambient environment around your system. Click Yes on the choice and then Continue. Select your inductor terminals. For a slice case, those are the inductor faces where the geometry has been cut. In this case, since the full inductor had 2 windings and has been cut, we can select either all 4 faces or only 2 faces, both cut faces for one of the windings. Click Create Air to automatically generate the airbox. Once the airbox is generated, you will be redirected to the Group Creation window. Here you will see a list of groups you need to define for your system, such as which one is the workpiece, where are the inductor terminals, etc. You will see that the selected inductor and its terminals have already been assigned automatically, so we need to assign roles to the other inductor and its terminals, as well as to the workpiece and its surface. First, to group both inductor windings as one inductor, we need to select the terminal 1 group and choose the same side face of the other winding. Click Assign Terminal 1. CENOS will ask if you want to reassign a role, since one of the faces already had a role of terminal 1. Click Reassign. After that, do the same thing for terminal 2 and for inductor. Select the other winding as well. Before, I mentioned that you could also select all 4 cut plane faces when generating the airbox. In this case, each inductor winding would be its own inductor group. This will not change anything more than the fact that you would need to input the power value twice, once for each inductor group. Once that is done, we can move on to the workpiece. Select the group workpiece, select the corresponding volume from the list or directly from the screen, and click Assign Workpiece. Next, we need to define the workpiece surface group. Here we do the same. Select the group workpiece surface. After that, select the corresponding faces. You can filter the faces by the workpiece and click Select All to ease the process. However, note that since this is a slice case, so it is only a fragment of a full 3D geometry, the workpiece surface does not include the 2 faces that are on the cut planes. We need to deselect those faces, which we can do by holding Shift and clicking on the 2 faces in the geometry preview. You can see that 2 faces have now been selected. After this, click Assign Workpiece Surface. The 2 unselected workpiece faces can be also grouped together as they will have the same properties, so we will not need to input the same properties 2 times. Under all of the assigned roles, you can see a drop-down menu Other. Here, choose the option Workpiece Symmetry. In the selection menu, select the 2 faces and click Assign Workpiece Symmetry. Next, since this is a slice case, we need to modify the airbox role as well. Go to the Infinity group and click Unmerge. In the pop-up window, click Remove Role and Unmerge. Next, go to the Infinity role again and select the 3 air faces that are not on the cut plane. All 3 of them will be selected together. Click Assign Infinity. And for the other 2 faces that are on the cut plane, do the same thing as for the workpiece. This time choose Other and assign the role. Now all of the geometry roles and groups have been created. You can rename each group by clicking the Edit button next to the name. Now we can go to Physics for physics definition. You will be redirected to the Physics window where physical definitions are present. On the left, you can see the preview window of your geometry, but on the right, the actual physical definitions. You can navigate physics through the domain tabs above the physical definitions. In the Simulation Control window, define the simulation as a slice of 36 degrees, transient with 20 kHz frequency, 3 seconds end time, and 0.1 second time step. For computation algorithm, leave automatic. Select Workpiece 1 from Domain bar. For material, click Select and choose Medium Carbon Steel 1045. Under Thermal Analysis, leave everything as it has been automatically assigned. Under Electromagnetics, you will see that the symmetry boundary conditions have been assigned automatically as well. Switch to Inductor in Domain bar. You will see that the material has been automatically assigned. Under Electromagnetics, choose Power for Terminal 1-1, Ground for Terminal 2-1. The full 3D case would have power of 37,000 watts. However, this case only has 1/10 of the whole geometry, so the power has to be divided accordingly. So here we input 3,700 watts. Switch to Air tab. You will see that under Electromagnetics, the role Other 1 does not have the boundary conditions set. Set it as flux parallel, the same as for the workpiece. With this, all of the physics parameters have been defined, and you can click Run to save and run the case. After calculating the case, CENOS will automatically open the results for you. Here you can see all kinds of values as usual, with one exception that is specific to sliced cases. Here in the performance plots, you will see that the active power has been calculated to represent the total power for the whole system. As I mentioned before, the full system would have 37,000 watts.